So if you don't want a new seating chart tomorrow. Okay, so today we are doing trig functions of any angle. So these ones are going to be given to us on a coordinate plane. And it relates the trig functions to x and y, so the coordinate points x and y, and then r is the radius if we were going to make a circle, which is found using the Pythagorean theorem, and our r can't be equal to 0. So I have all of these up here. I actually don't remember the letters, and I just remember it based on when I draw it out. So I'll show you what I mean. Number 1 says let negative 3, 4 be a point on the terminal side of theta. I don't know why it says that's shown in the figure. There's no figure. I'm going to draw this. So negative 3, 4 is right here. So if I draw a triangle out like this, what is my side length right here? Negative 3, because I'm on the coordinate plane, it can be negative. And then my length right here, 4. So then notice this is a right triangle. How am I going to find that hypotenuse? Pythagorean theorem. So I'm going to add negative 3 squared to 4 squared, and it should give me that hypotenuse. Okay, so what is negative 3 squared? 9, and 4 squared? Okay, 9 plus 16 is? Okay, and then I want to take the square root of both sides. 5. So my reference angle is right here. Because you always connect to the x-axis on these. So now I want to find my trig functions. So to find sine of theta, what is this going to be? What's my opposite side? 4 over 5. Cosine of theta? Negative 3 over 5. Tangent of theta? Four over negative 3. Then cosecant flips sine. So flipping 4/5 turns it into secant flips cosine. So that gives me negative 5/3. And then cotangent flips tangent. Questions here? So, next thing is the sign of a trig function in the coordinate plane. Depends on the quadrant it lies in. Remember, we have our quadrants 1, 2, 3, and 4. It goes counterclockwise. The way I remember it is all of them are positive in the first, so it says that on the words. Only sine and cosecant are positive in the second. In the third, only tangent and cotangent. And in the fourth, only cosine and secant. So the way I remember this is all students take calculus.
What is the A?
A stands for all. All of them are positive. No, all, sine, tangent, cosine.
Okay.
Okay? Okay, so looking at number 3, it tells me sine is negative. Where is sine? Right now I'm just going to focus on the fact that sine's negative. Where is sine negative? And it's negative in 2 of them. Wait, sine's not negative in 2. So this chart, this one's telling me where they're positive.
Oh.
2 and 3. No, not 2 and 3.
3 and 4. 3 and 4. Look at that. We got that. Yeah, we're there.
Okay. Then it also says tangent is greater than 0. Does greater than 0 mean positive or negative? Positive. So where is tangent positive? 1.
1 and 3.
Okay, so where are these two overlapping?
1 and 3.
Where are the yellow and orange overlapping? 3. Okay. So sine is opposite over hypotenuse. So I'm going to put my numbers back on here. I have 2 and 3. And whenever I'm working with triangles on the coordinate plane, the hypotenuse is always positive. So that means the 2 has to get the negative. Okay. So now I need to figure out my missing side. So I'm going to use the Pythagorean theorem. I'm going to have negative 2 squared. I'm going to use b because I don't know that side length. And it should equal 3 squared. Okay, so what is negative 2 squared? 4. And 3 squared? So then I want to go ahead and subtract 4 from both sides. Okay, then I go to take the square root, and I get, what? I get 5? Okay, square root of 5. Those are 2 different numbers. Okay, this problem wants me to find cosine of theta and cotangent of theta. So cosine is, oh, my angle's right here. Cosine is adjacent over hypotenuse. So what's my adjacent side? Huh? And my hypotenuse? Okay. And then the other one is cotangent of theta that it wants me to find. So cotangent is, wait, yeah, bro? It's always the one closest to the origin. No. Cotangent is always adjacent over opposite. Yep, square root of 5 over negative 2. So this is my answer here. Questions here? Because sine is, if you remember, like SOHCAHTOA. So sine is always opposite over hypotenuse, and my angle is always next to the origin. So the opposite is here, and the hypotenuse is here. Hypotenuses can't be negative, so that's why I'm doing the negative one. Yeah, so it was a negative number, right? So I know I was looking for where sine had to be negative. Remember on the front I had that chart? All students take calculus. That tells me where they're positive. So all of them are positive. Oops, that's not on the screen. All of the are positive in the first quadrant. Only sine is positive in the second. So that means sine has to be negative in these two. That's why I highlighted those ones with yellow. Then I was looking for where tangent was positive because it told me it was greater than 0. And so tangent's positive in the first one and the third one. So I highlighted those two to see where they overlap.
So sine is positive for the floor.
Yes. Okay, so last one. It wants me to evaluate the cosine and tangent functions at the angles 0, pi halves, and 3 pi halves. So let me draw this out. Remember, we always start at 0 right here. Pi halves is how much I count by in a circle for radians. So then this would be pi, and this would be 3 pi halves. Okay. So then what I want to do is I am going to, on these, I'm going to give all of these a corner point. This is going to be 1, 0. This one is going to be 0, 1. This one is negative 1, 0. And this one is 0, negative 1. Okay. And then I want to find the cosine and tangent of each of these three. So on this one, I'm finding cosine of, no, these aren't degrees, these are radians. Cosine of 0. So I am actually going to use these formulas from the front. I'm going to use my x value over my radius, and then on the circle, everything has a radius of 1. Or on the circle, on the graph. Okay. So cosine is x over r. So at 0, my x value is 1, and my r is 1. So my cosine of 0 is 1. Then I'm going to do the same thing for cosine pi halves. What is my x value? And my r? 0 divided by 1. 0. And then I'm going to do the same thing for cosine 3 pi halves. So what's my x value here? My r value. So it's 0. Then it also wanted me to do the same thing for tangent. Tangent is y over x. So at 0, what's my y value? Y. And x? that gets me 0. Then I'm going to do the same thing for tangent of pi halves. So what's my y value at pi halves? And my x value? 1 divided by 0? Undefined. And then I'm going to do the same thing for tangent 3 pi halves. So what's my y value here? Well, I want to write the fraction first. -1, and then my x value. And then this is undefined. So these ones are actually using the formulas on the front whenever I'm on the exact. When I'm on an axis.